Hi, everybody, and welcome back to part three. What we're going to be doing for this section, it's going to be a little bit different than the other two. In this one, we're only going to be focusing on practice problems when it comes to sex-linked inheritance. So the way that this is going to work is I'll go ahead and read you the problem. I'll give everybody about 5 seconds to pause the video, give it a try on your own, and then I want you to go ahead and come back to the video and compare your answers to mine and compare the process to mine as well. So let's go ahead and get started. In our very first question, it says red-green color blindness is a recessive sex-linked trait. The gene that controls red and green vision is located on the X chromosome. Harry is red-green colorblind, but his wife Holly is not. They want to have kids and wonder if any of their kids could inherit Harry's colorblindness. Their family genetic pedigree is shown below. So what we're going to try to see is we're trying to identify what are the probability or chances that they could have a male child who's colorblind, and what are the chances they could have a female child who's colorblind. So I'm going to go ahead and give you about 5 seconds to pause this, give this a try, and we'll go ahead and come back together and check it out. All right, welcome back, and let's go ahead and figure this out together. So one of the very first things we're going to go ahead and see is who's got what. So right here, we know Harry is red-green colorblind, and we know Holly is not. What we have here is we have Heather, right, who's Holly's mother, genotype over here. So with that information, we're going to go ahead and start filling some of this out. We know Harry is going to be a male, so we know it's going to be X and Y. And we know that it's X-linked. So that means it's only following the X chromosome, it's not following the Y. So in this case, we know Harry is colorblind, so it's going to be a little r here. And in this case, Henry, we need to go ahead and figure out exactly what he's going to be. We know Henry's a male because it's going to be Henry and Heather who's going to have Holly. So in this case, we know this is going to be X, Y, and we know that this is going to be X, X. Now we know Henry is not shaded for color blindness here, so we know that this is going to be a big R for normal. And then in this case, we know Heather is big R, so if we go ahead and cross these down, then we should know that Holly is going to also be big R as well. Because if Henry has a big R and is normal, and Heather is homozygous dominant for normal vision, then by default, there is no color blindness gene to pass on. So in this case, we know it would be big R. Okay, so what we're going to do is we're going to be taking Harry and Holly. So Holly right here, and then Harry right here, and we're going to cross these two. So Holly is going to be an X, big R, X, big R. We know Harry is X, little r, and then Y. So we're going to go ahead and do the X's first. So we're going to go ahead and put X, 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 Y, X, and then Y. And then we're going to go ahead and put the R's down. So in this case, we have big R here, little r, big R, and big R. So now that we went ahead and completed our Punnett square, we're going to go ahead and do our analysis. So we know that this part right here is our males, and we know up top is our females. So we have that 50-50 split. So what we're going to do is we're going to go and identify for males, what are the chances? So in this case, we have our males down here. We have only one X, so it's only following one. And we can see that's a big R for here and a big R for here. So in this case, we know they have a 0% chance of having a male who's going to be colorblind. And then what's the probability of a female that would be colorblind? In this case, we have big R here, and then little r. So in this case, it's going to be heterozygous. So in this case, it would be a 0% chance as well. So in this case, if they were to go ahead and have any kids, they would have a 0% chance of a male with color blindness and a 0% chance of a female with color blindness. But those females would be carriers. So this is what that would look like, all written out. All right, so let's go ahead and check out our second problem. So in this case, it says vitamin D resistant rickets is a dominant sex-linked trait. Individuals with this disorder have bone pain and growth deficiencies. The gene that controls this disorder is located on the X chromosome. George has vitamin D resistant rickets, but his wife Angela does not. They want to have kids and wonder if any of their kids can inherit the condition. Okay, so here are those questions, and I'll go ahead and give everybody about 5 seconds to go ahead and fill these out, and then we'll come back together and check it out. All right, welcome back. So let's go ahead and check this out. So what I'm going to do is I'm going to go ahead and highlight some of the important pieces of information. We know vitamin D resistant rickets is a dominant sex-linked trait. So you can see right here for rickets, it's going to be a big D. And then we know it's located on the X chromosome. We know George has this vitamin D and his wife does not. They want to have kids and wonder if their kids can have this condition. So what we're going to do is we're going to go ahead and fill this out. So we know George is a male, so we know we have an X and then a Y. You know, Angela is his wife, so it's going to be XX. Okay, so in this case, we know Angela does not have it. And in order for it to be normal, it needs to be homozygous recessive. So we know we have little d here. George does have it, and again, we know that this is a dominant trait, so that means it's going to be a big D right there. And it's only showing up on the X chromosome because it is X-linked, not Y-linked. So just like that, we were able to identify George's genotype. George is a male, XY. George has rickets. Rickets is a dominant trait, so it's going to be a big D on our superscript. Angela is going to be a female, XX. In this case, Angela does not have it, and because it is a dominant trait, in order to get normal, we need to have that little d, which is going to be recessive. So in this case, it would be little d. Remember, it needs to be homozygous recessive, so both have to be little d in order to show normal. So now that we have this, we're going to go ahead and fill out our Punnett square. So Angela, X, X, George, X, Y. And then we're going to go ahead and fill out the genes for rickets. So Angela is normal, so we have little d. And then George is going to be dominant, so he has it. So in this case, big D. So what we're going to do is we're going to go ahead and do that Punnett square now. So again, I'm going to put the X's and Y's down first. So X from here, X, X, here, X down, X over. So XX, two females up top, X down here, Y over here, X down here, and then Y over here. So now that we went ahead and did our X's and Y's, we're going to go ahead and do our rickets now. So in this case, we have big D, big D, little d down here, and then finally little d down here. So we went ahead and completed our Punnett square. So now we're going to go and do our analysis. We're going to read the first question. What is the probability that a male child would have vitamin D resistant rickets? So what we're going to do is we're going to go ahead and look for our males, which are going to be down here because remember, males are going to be XY. And then we're going to see if they have rickets or not. So remember, rickets has to be a dominant big D. Normal is going to be little d. So over here, we see we have a little d here. It's not on the Y. It's only going to be linked to the X. So it's only following the X chromosome. So in this case, we don't have anything. So this person does not have rickets. They are going to be normal. Same thing over here. We can see it's an X linked. We have a little d. There's nothing on the Y. So in this case, there is a 0% chance of having a male with rickets. What is the probability that a female child would have vitamin D resistant rickets? So in this case, what we're going to do is we're going to go ahead and look for our females, which are going to be up here. And then remember, because rickets is a dominant trait, if there's just one big D, they are going to have rickets. The only way for them to be normal is going to be homozygous recessive. So in this case, we are not going to have any heterozygous options for having normal. So in this case, we're going to go ahead and take a look. We see we have big D here, little d, so they are going to be heterozygous. But in this case, because rickets is a dominant gene, they are going to have it. So right here, they are going to have rickets. And then again, XX, big D, little d, sex linked to the X. So you can see we have our dominant trait here. So they are going to have it. So unfortunately for them, they are going to have a 100% chance of having a female that is going to have rickets. Okay, and that's what that should have looked like for you. All right, and that is going to conclude our practice portion. So again, if you do have any questions, comments, or concerns, please feel free to reach out. And I look forward to seeing everybody in the next lesson.